Hello, this is Mr. Reynolds, and we're going to take a look at some scientific notation, which is a little bit of math, and I'm not planning on killing you with it. I'm going to give you a little bit today, a little bit tomorrow, so a little bit of it. And um, basically, we're in chemistry, we're dealing with uh, in one little piece of salt that you see on the table. There's probably 500,000 sodium chloride formula units present in there. Okay. So instead of saying 500,000 all the time or 10 bazillion, they like to use chemistry and some other sciences like to use scientific notation. And so basically look at a couple things. Basically in 1,000, if we change that to scientific notation, we have one number in front of the decimal, and then times 10 to the, how many places you moved it. The decimal did start out right here behind the 1,000, and we moved it over 3 places to the left. That's positive 3. So 1,000 is 1.0 times 10 to the third. Okay, 200, that decimal point would be there, is 2.0 times 10 to the second. Okay, we move the decimal 2 places to the left. All right, so the exponent goes in positive direction 2. Okay, so big numbers, we're going to have positive things over here. 50,000, okay, would be 5 times 10 to the, okay, 10, 1, 2, 1, 2, 3, 4. I move it 4 to the left, so 5 times 10 to the fourth. Okay, this is a form that they like to use. Okay, one other thing that we did before, you did moles before. We said that was a number. Remember, we're dealing with really, really, really small things, so it takes a lot of them to even be able to do, and to even see it. To even see a little speck of salt takes a whole lot. 1 mole is equal to 6.022 times 10 to the 23rd. Okay, so that's 23 zeros after this decimal point. Here's 1, 2, 3. 3 spaces, and then there's 20 more zeros after it. So it's a big, 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 long number. I'm going to write out this one time, and we won't have to do that again. There's 3. I need 20 more. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Comma every 3 for my thousands. So that's a huge number, okay? That is equal to 6.022 times 10 to the 23rd, which is 1 mole, okay? Anyway, that's a number that you'll be hearing. We mentioned moles before is a measurement for concentration, okay? And we said, I mean, all these atoms are different sizes, different numbers of them. They bond differently. The only thing they could find in common, like I said, like donuts, a dozen means 12. Okay, 1 mole means a number. 1 mole means this, 6.022 times 10 to the 23rd. All right, that is 1 mole. Okay, up here we took big numbers and changed them into scientific notation over here. I'm going to go to the next slide. We need to take small numbers. Oh, like this is really, really small. 0.000056. Okay. Changing that into scientific notation, where it's a real small number, we're going to change into it. Remember, on the previous page, we changed big things, big numbers. 670,000. We changed into scientific notation. That's a big number. That would be 6.7 times 10 to the, and we move, the decimal was here, 1, 2, 3, 4, 5 places we had to move it. So 10 to the 5th. Okay. This, a small number, is going to be a little bit different. Okay. Where we want it to be one number in front of the decimal. Okay, one number in front of the decimal, so 5.6 is what we'll end up at, times 10 to the, if I'm moving it to the right, I'm going 1, 2, 3, 4, 5, 6 to the -6. So the direction going to the right is -6, right? If you see something like this, where it's a negative, you know it's a small number, okay? If you see a positive exponent like this, you know it's a big number, okay? So let's keep staying with the small ones. 0.0047 is going to be equal to, I need to move it 1, 2, 3 places. I want 1 in front of the decimal. So 4.7 times 10 to the 1, 2, 3, to the -3rd. Okay. 0.000033 is going to be 3.3 times 10 to the 1, 2, 3, 4, 5 to the right is to the -5th. Okay. All right. Again, if it's a big number, 2,420. I'm going to need all these numbers besides zeros are going to need to show. And it's got decimals here, and 1, 2, 3 to the left. So the answer is going to be 2.42. Again, one number in front of the decimal, 2.42 times 10 to the, I moved it 3 places to the left. 2.42 times 10 to the 3rd. All right. One more time, a small number, 0.00000000. That's 1, 2, 3, 4, 5, 6, 7, 8, 9 zeros. I count 9 zeros, and then my number, which I'm going to have to move past this to put the decimal here when it's time. Okay. 9 zeros. I move it one more, so that's 10 places. I'm going to have to move it to the right. Okay. I want one number, one whole number in front of the decimal. 8.4 times 10 to the, and I had to move it 10 places over to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 zeros and one more place. That's 10 places, and that's a negative direction. Okay? And that's all for this. Thank you.